I'm going to throw up a video, as the title implies, about building a carbon fiber intake manifold for a Cummins 8.3 diesel engine. Now, some of you know that are familiar with my channel, you probably know what this is about, but let me start the video out just kind of explaining to you in detail what I'm doing and why I'm doing it. So, the other thing is, there's maybe some of you that are here watching this video because I'm building something out of carbon fiber or making a mold for carbon fiber build. I have never done this before, so I'm kind of flying by the seat of my pants. So you're going to learn as I learn what to do, what not to do, and how to do it. So here we go, carbon fiber intake manifold build. Also the mold build too. That comes first before the carbon fiber. Okay, so I had gone out and gotten this foam, and I'd addressed that in a previous clip. I called it part of a shop update, but in reality this is going to become the first part of the mold build for this air intake for the Cummins 8.3. Now, I had discussed in previous videos regarding the haul truck about the intake manifold. So let me take you over there, and I'll kind of show you what I had discussed about the intake manifold originally. Okay, so here is the original intake manifold off of the 8.3 Cummins. And what it is it's a plate that goes over the intake plenum off of the Cummins, and it has a couple of ports in the side of it. There was a elbow that sat on the top of this faced out, which got a silicone boot attached to it, silicone hose that was fed. I'm not sure if this thing was intercooled or not, so whether it came from an intercooler or directly from the turbo, regardless of the point. So this was the intake manifold. In the intake manifold ports, there was a couple of heater injectors. Now, in 5967 Cummins, you know that they have a grid heater system on the intake manifold. This thing actually had like diesel fuel fed little burners that went into it. Had a wire on it that would ignite the diesel fuel in the intake manifold and create a warm air charge that goes into the cylinder when starting it. But as you can see, it is very restricted. Let me bring you back. Sorry, I got interrupted with a phone call. But anyways, it was very restricted going in there. Now, let me take you over to the air plenum and show you what the plenum on the head looks like. So here is the air plenum on the head for the 8.3 Cummins. And as you can see, it's a long, narrow slot. And what happens is, and let me just move the light down, you can see the intake runners that go in to feed the intake valves of the cylinders. Now, number 6 is back there, and number 1 and 2 are kind of up here. But basically, that original intake manifold that I showed you that had the heaters in it was very restricted given the fact of the size of the port that goes into the head. Now, let me take you back over there. So what I was going to do is build an air intake out of metal. And what it would have done is been domed and open that entire way. So that opening is approximately 2 1/8 inches wide. So what it would have been is approximately 2 inches, because I would have had to hold it back a little bit for welds so that I could get bolts and stuff in beside the sidewalls and the welds back into the flange of that intake manifold. So it's approximately 2 inches, let's say, by 21 inches long. And what I was going to do is build it out of, have a flanged runner that bolts onto the plenum of the head, and then have a domed shape canopy over the top of it with a 4-inch port in the side of it. But the only problem with that is, if you look at it from a side view, you have the flanged area and a narrow 2-inch dome with a 4-inch feed into it, and what it is very restricted in the airflow going into it. What it does is smashes into that back wall of it. So what my thought is to make a molded type of thing that would flow better into it. The air would flow better into it, and you wouldn't have that turbulence that's created by the air hitting that back wall, a straight back wall. So let me take you back over to the material. So what I'm going to do with this material, this foam material, is I'm going to cut it and layer it up on top of each other, and the contact cement is to kind of glue it together. So what I do is layer it up on top of each other. Now, this is probably going to be, there's probably going to be another layer on top of this. This is going to be the bottom 3 layers, and then what is going to happen is they're going to start getting bigger so that I can configure the intake and shape it over, dome it over, and configure the air intake into the side of it. So off of the bottom of these, or the top of these, when it starts coming out, it'll be curved into it and shaped up into that intake manifold to give it some support and rigidity of that 4-inch round intake. Now, there's a couple of ways you can make molds for fiberglass or carbon fiber material. Sorry. You can, I'm making a mold where I'm going to lay it over the top of it, and I kind of have to. So the mold is only going to be a one-time use, because actually on the 4-inch tubed intake that goes into it, I'm going to have to dig out the mold out of the inside of it. Now, I could form it in 2 different pieces and kind of flange it together, but that would be harder to do and kind of look stupid. I mean, having a tubed flange together wouldn't be a great idea, or you wouldn't be able to adapt the silicone hose that provides the air from the intercooler to it. But anyways, so here it is, and I've discussed the material. So what'll happen is I will create that shape, sand this stuff down, and then it's got to be sealed. So what I'll do is form it, sand it, seal it. Now, how I seal it is going to be a question. There could be body filler used to kind of take out any imperfections in the forming process, but there also could be a release agent for the mold used to seal the foam also. But we will get to that as this build of the mold progresses along. So here we are over to the workbench, and as I had stated before in the previous clip, I had cut a couple of pieces out. Now how I'm cutting it out is I'm just taking a knife and cutting along it. If I was to do this, be building these things on a daily basis, or just on a regular basis, let's put it, the way that you should actually cut this stuff is with a hot wire method. And what you do is you take a heated wire, and it can be like on a table, it's almost like a table saw, except instead of using a blade, it uses a hot wire. And you push the material, guide the material through, and the wire slices it off, and it also, let's use the term, cauterizes the side of it, like a hot thing kind of seals the blood vessels when they use it. So what I'm doing is just cutting it off. I'm going to go the same size as this, another one high, and then they're going to start getting bigger and wider to kind of form the tube intake and the curved surface. One of the things that guides how tall this bottom section has to be is the bolts that go into the flanged area that secure it, because when this intake comes out, there will be bolts under here that have to be gotten into, so I need enough room underneath here to be able to get the bolt in to tighten the flange up. So kind of what I think I'm going to do now is start creating bigger pieces that will start forming the intake of it. So in other words, the piece will be back here like this, and for example, maybe the next piece will be cut like this. But I'll bring it back as I do it. So I cut this piece out, and I've marked a center line down through here, and what I'm going to do is cut along these areas here. This is going to be a little bit trickier because there's actually kind of a grain pattern that's into this foam. So see, I wanted to follow that grain. That's why I said offcuts like that, or the ends where it doesn't cut really good like it does on the side. Going this way with the cut is a lot easier than cutting it that way. You get a better cut line. But anyways, that's what the body filler will have to deal with, is those imperfections in it, just to fill it out and get it to the dimensions that I want it to be, or that it needs to be.
You're probably wondering why I'm not using a utility knife. Well, to be totally honest with you, I couldn't find it. I did find it afterwards, but even though a utility knife, the blade wouldn't have gone through that total piece of 1-inch foam. So, as you can see, I smartened up and started using the saw.
Okay, so there's 4 of them, but it doesn't quite equal 4 inches. Well, it does. It's probably a 16th under. So I think I'm going to add a 5th one, just to be safe on the thing. I've made this thing 6 inches wide so that I've got enough room there. I think I'm going to add a 6th one. It's not going to hurt. I mean, it's going to be a little more to take off in the shaping process, but it'll all be good. Okay, so I've got the 5th one cut it off camera, laid it out and cut it off camera. So now that I've got 5 of them cut, I'm going to start laminating them together, these 5 pieces. I'm not sure if I'm going to laminate the narrow piece on the bottom. That's going to be the bottom where to give me upward spacing so that I can get the bolts into the flange. But if I get these 5 pieces laminated together, that'll give me a solid piece that I can start shaping. So I got to go through that got to go through the contact cement and read the directions for it before I start using it. What I've started doing is using contact cement to tack these up. Now these 2 pieces are glued together. I just prepped this one. What I'm going to do is wait for it to get tacky. Do is weight it. I'll put a piece of plywood over it and put some weight on top of it to kind of compress it in there. Okay, I'm going to do the last one, then I'll bring it back when I go to weight it. Okay, I kind of explained to you that I was going to put some weight on it. I did put some weight on it. I took a piece of wood, actually a piece of the table that I cut off, and put it on top of it with a brake rotor on top of that to try and compress it. Now, I filmed it. I don't know what happened to it. I can't find the videos that I shot of it, but let me take you to a spot of after what happened. What happened was the weight was not distributed, and it kind of compressed the foam in the front where the 4-inch silicone tube is going to be bolted onto this. It compressed it too much, and it was down to like 3.5 inches where I want that intake 4 inches. So what you're going to see now is clips of me adding some foam to that area to try and build it back up again. So I'm back over here to the mold, and the last thing that I clipped that I showed you is where I set the wood on it and that weight on it. Well, it compressed it, but it compressed it too much. I want 4 inches on that intake, and look at what it did. It compressed it so that it's down to 3.5. So what I did is I cut a couple of pieces. I'm gonna put them on here, get the glue back out again, and put these things on there, and just use that. Then I'll let it dry. I'm not gonna compress it again, but I'll let it dry and start shaping. Okay, so this is going to do it for part 1. In part 2, I'm going to start shaping the mold, the foam, the styrofoam. What I'll do is I'm going to just throw you a little pick and pick up here, kind of showing you where it's going to, but all of that will happen in part 2 of the carbon fiber intake build for the Cummins engine. So thanks for watching, guys. Hope you enjoyed it. Hit that like button, comment, rate, subscribe.